Hey everybody, uh, let me check the video. I hope you can see me now. That's our next podcast, now our next webinar about object-oriented programming. So let me check the connection. Can somebody say whether you can see me and hear me properly in the chat? It's a little bit rainy now where I am, and for that reason the sound may be a little bit uh, noisy because it's raining outside. So can you see me and can you hear me? Please confirm. Okay. Sounds good. So the topic now is the validation of the objects. Uh, the sound is off to one side. Let me check. No, I think you should hear me properly. 1, 2, 3. Anyway, I'll continue. If you really have some problems, then let me know. So we will discuss object validation. I wrote a blog post about that maybe a month ago. So where I said that I kind of rethink what I said like a few years ago about the code in constructors. I mentioned that in the book, in the code, in the Elegant Objects book, and I mentioned that in the blog post, which is 3 years old now. It says that constructors must be code-free. So in a properly designed objects, in object-oriented programming, we should not put any code in our constructors. So object constructors, they are supposed to just take what's coming in, all the arguments, all the parameters, and just encapsulate them in the object attributes. That's all we may have in the constructor. But now and this is the opinion I was strongly holding at. I was strongly, believing in this concept for a few years, and I was trying to design all my objects in that way. So no code in constructors, only the encapsulation of the incoming attributes, incoming data, incoming objects. But now I think it's a little bit. Well, I think this statement, this claim, this concept needs a little bit of refinement, and that's why I wrote an article about that, and that's what we're going to talk now, and I will show you some examples of what I mean. Sometimes, so there are two different situations, two different scenarios of when we are getting something into the constructor, and we do need sometimes to do something with the incoming information, with the incoming objects. In most cases, not in most cases, but there are two different situations. In one case, in one situation, for one set of purposes, we don't need to deal with the incoming objects in the constructor, but for some other set of purposes, we do need to do that. So let's go to the code, which I want to show you now, and it's going to be Java, and we will try to write a little bit of code. We will try to write a test, and we'll demonstrate what I have in mind. So here's the class, which is from the farm project from Xerocracy. It's a live code, which you definitely know what Xerocracy is. It's a project which I'm working in right now with a group of programmers, and we are trying to automate the management of software projects. And to do that, we have this farm open source code, which contains a number of classes, and one class we'll take a look right now. It's called issue of event. What it does is this code, this platform is listening to GitHub webhooks. So when you do something in the GitHub and your GitHub repository is connected to our platform, then GitHub will send webhooks, the JSON HTTP request to our platform. And inside that JSON code, there will be some information about what happened there in the repository. And our platform has to react to that. So we're listening to the incoming JSON data, and we react to them. In most cases, the JSON data comes in with the information about the issue, the GitHub issue, where that event happened. So where that something happened and the situation happened which we need to react to, like some comment was posted or the issue was opened or the issue was closed, something like that. So the information is coming in the JSON, in a JSON block of data. So we need to extract the information about what is the issue that the JSON data is pointing to. So for example, it may look like that. Well, not for example, but really it looks like that. The data comes in, and in JSON it will look something like that. Issue, I think so. Yeah, it's issue, and then it's going to be that's how the JSON is coming from GitHub. Something like, I'm making a comment because just to format it properly. So they will send huge amount of data inside the JSON, but aside from all the other stuff, there will be that piece of information. There will be way more data, but we need this number. We need this number, and we need the name of the repository. So it will be something like that. Not a good JSON editor. Say, for example. So here's what we're gonna get, and that's just pure data. And as you know, we had I think a webinar about that, and I told about that on the blog, that the best way to parse that information is not to parse it like with the parser, but instead to create an object which will encapsulate that information. Let's put it in the unit test. Let's start with the test. Just will help us, understand it better. So I will create a new test because we don't have a test for this class, issue of event. It's easy. It will be easier to I usually copy my code from another test. Let me check that you see what I'm typing in. Okay. Parses incoming JSON. So this is what I would like to see. Let's get this stuff from here. Let's say we have this JSON. Let me check. For the purpose of testing. That. Right? That's going to be our JSON. Repository. Correct me if something is wrong here. Like I said, I'm not a really good JSON designer. This is the start. Let's put it here, and this is the end. So imagine this is the JSON coming from GitHub, and then we want to get an issue. Issue is the interface from the library called JCabby GitHub, where issue is something which you can deal with. For example, you can say issue dot, you can say this, we can use smart class, issue smart issue and then title. So imagine something happened in the issue in the GitHub, and we are receiving, we're getting the JSON piece of code, piece of data, and then we create somehow. I'll explain now how. So we create the issue, and then we're getting the title of that issue. So this one, this code, this .title, will make another request to GitHub and retrieve the title from there. So here, HTTP GET will happen. But the question is, what will happen here? So how do we parse? The traditional way is probably to do something like that. I don't know, issue, parser, parse, JSON. This is not how you design your object-oriented code. Instead, what we are doing is saying new issue of event. So we say this issue of event is actually, it implements the interface issue. So it is an issue. It's not a parser of the JSON, but it is an issue which you can deal with. And what's going to happen inside this class is none of my business. So this, you should understand the concept. It's not a parser. I'm not parsing the data, creating something, but I'm just making an object of a class which knows how to deal with JSON. Of course, there are going to be some other parameters which we'll see now. But the principle is that we pass the JSON there, and then the class starts to behave like a real issue, like a real GitHub issue, and you can say .title, and the title will be retrieved. So now the question is, what do we encapsulate? We cannot encapsulate JSON, it has to be JSON object, so we need some JSON parser, JSON create, I think it's like object, yeah, that's the parser. You see, these guys are, not really object-oriented guys. So we do reader. How do we create this string reader? I think yes, JSON. Okay, that's the second parameter, and the first one we need to pass the GitHub object. Let's make it this one. Create parser and get object. Yeah, boom, it works. So we are sending two arguments here. The first one is actual the GitHub object, which represents like a GitHub server. Let's put it this way. And here we parse the JSON and we send the actual JSON object. So these are two coordinates of the issue. I said in the Elegant Objects book that everything we encapsulate in an object, everything is a part of the coordinate of the dependencies our object represents. So here the question is, so who does that object, this one, represent? So who, this issue, what exactly it represents? It represents two things. It represents the GitHub server and the JSON which came to us from the webhook. So there are two things which perfectly and non-ambiguously point us to the issue in GitHub. That's the idea. I hope you understand what it is. And this is really pretty object-oriented. Now let's get into it and see how we can, let's start talking about object validation. Maybe first let's run it and see whether it works. Just for, maybe it will fail, but I don't know. I haven't done it before. So let's see. I'm just running it. Just this primitive test. Most probably this title will fail because we don't have this in this fake GitHub server. We don't have the issue with this number 123 in this repository. So most likely it will fail. But we can create in this fake GitHub server. This is MK stands for mock. So it's a mock version of GitHub. It's not a real GitHub server. It's a mock version, which is empty when we started. So it doesn't have the repository with this name. The repository doesn't have the issue number. So it doesn't have all of that. But we can make it. We can do it. We can configure it, so it will have all that stuff. Let's see how it's done in other places. Oops, JSON parser get object or get object stream is only valid for start object parser state, but current parser state is null. Oh, that's nice. I don't understand what it means. Create parser, string reader, get object. See, I'm not really sure how to parse the maybe reader. I don't know. Let's try this one. I'm always, you know, a little bit parser, again parser, but it's not a parser anymore. It's a reader. JSON create reader, string reader. What do I need? Read? Read array. No. Do you know how it works? It's pretty messy API if you ask me, but create. Yeah, the reader should work. Maybe it wants the input stream. Let's cactus. I don't know. For start object. Maybe the JSON is wrong. Issue, repository. Let me check your chat. Maybe you can suggest something. Create reader. Let me Google it. We need an example of that. Yeah, the example shows exactly that. String reader, JSON. I'm sorry for keeping you waiting, but we need the JSON. Reader close. Okay, let's do it first. This one just to check that it works. Oh, sorry. I think that this one is wrong. So the join, yeah. Sorry, my bad. So it should be like that. The content was wrong of the reader. Yeah, now it's better. So yeah, you see it says repository doesn't exist. So this fake server doesn't have the repository. That's why it says we don't have the information. So let's create that repository. Let's make the server first, and then let's say GitHub repos create test private false. So we're like sending the real command, but to the fake repository. So instead we'll put test here. Test. Okay, now the repository will exist there. And it should report something about the missing issue, I guess, when we're trying to get the title from it. Repository test doesn't exist. Nice. Yeah, sorry. So the first name is test, but when we create GitHub, we need to say who's the owner of GitHub. So it's the owner is Jeff, and repository is test. This way. Yeah. So we create a fake server. We like relogging. So we pretend that we are Jeff, and then we create. Yeah, you see, issue Jeff test 123 doesn't exist in GitHub. Okay, because there is no issue. So let's create an issue. This one returns a repository. So we say repo equals to this. Okay. Let's make it more readable. And then we need to create an issue. Issues, create, hello, that's the title, that's the description, and it will create the issue number 1. Obviously the repository is empty, and this is hello world. So the title should return, we can say matchers assert that title matchers equal to starts with hello. See my logic? So I create an issue with the hello world, the JSON is coming in, and I don't know what it wants. Okay, it moved in here, closer to the place where it's used. We can even make it more readable to get rid of the one extra variable, which we don't need. You know that every variable, every new variable is a potential, problem for maintainability. This is better. This is like, the stronger piece of code. Then we get back the title, and the title has to start with the hello. So if this test passes, and I'm 99% sure it will pass, then that's pretty clear example of how, it passes. Everything is good. So let's go one more time again of what's going on. So we are getting in the JSON data, and we have a fake or not fake, but the GitHub server. So we encapsulate these two things inside this object, inside this issue of event. And then we get the title from that, and the title comes back and it says hello, because the actual HTTP request is coming into this fake server. There is an actual HTTP request, but the server is fake. But that's all. And we check the information. So now let's go into that object here and see how it deals with these two guys who are coming in. So this is the constructor. It doesn't do anything aside from just encapsulating the data. So if I encapsulate, and now let's talk about two cases, two situations of when we provide the bad data into. So we can send something wrong. We can encapsulate something. We can send something which is not good, which is not acceptable for this particular object. For example, case number 1. This one is clean. This test is clean. So now let's create another test which will break the code, which will say fails on absent repository. So let's say John, there's no repository, no issue. Let's say let's reproduce the situation when GitHub is sending us the pull request, the webhook, the JSON data, and right after that JSON data arrives to us, right after that, the user deletes the repository on GitHub. May happen, right? So we're getting JSON, and then when we try to get back to GitHub and say, give us the title of the issue, there is no issue, no title, no repository. The user just created it, and immediately after that, click delete, and repository is gone. So we're obviously going to have the problem. So let's say we say issue number 1, full repository name is John, hello, and then we check the title, and the title is, let's just check it. So we want to see some exception, right? We expect the exception. And we can say expected, for example, I don't know, right? Illegal state exception, something. We need to expect something. So this test will have to confirm that if that situation happens, the code will break with an exception. And we can say, look, it should break here. We may think like that. Like, look, the GitHub is here, the issue is created, and it's obvious that we may think that it's obvious that the moment we create this issue of event, it's not legal, right? Because it points to something, it points to this repository which doesn't exist. This user John doesn't have repository hello. So this object, you may say so, that this object is an invalid state. But it's not true. This is wrong. Thinking like that is wrong. So this object is in the perfect state, but it will fail only when we start touching it, only when we start asking it to give us some information, and then it will go to the remote, dependencies, to the GitHub, and then it will break. So if I run the code like this with the commented out, so I commented out this line for the title, it will not break. So the test, the JUnit will say, look, expected exception, but there will be no exception here. So nothing happened there. So this code is perfectly legal, perfectly valid, this one. It just works because we don't do anything. We just instantiate objects. We don't give control to them. We don't let them work. We just make them. But the moment I touch the title, the moment I say, okay, now work for me, then it will break. I think now we will see the exception now. Yeah, but I think the type of, unexpected, blah, 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 but the real is illegal argument exception. Okay. So let's put it here. Let's run it again. So now the test will pass. I think so, because the code works like it's supposed to work. You see? So fails on absent repository. So the repository is absent, the test fails. Let's try another. Now everything is cool, because let's go back to the code. Let's see why it fails, where exactly it fails. So if I go to the issue of event, you see it doesn't fail here. Everything is good here because it's a perfectly legal object GitHub and the perfectly legal object JSON. So we just encapsulate them. So when we actually break is somewhere here in this method, which works when we start working with the object. So this is one of the methods. It doesn't matter how we get in there. You can look at the code yourself. But the point is that the exception happens here. Let's reproduce another more obvious problem. Let's say that the GitHub breaks us and fails on a broken JSON. Let's say GitHub is sending us something which looks like this. The empty object, nothing. So let's say GitHub is doing some mistake and they send us, instead of the real information, they send us just an empty object. No issue data, no repository data, nothing. So we don't even need this. We can say, okay. So we are supposed to fail here, right? Because there's, we cannot even find, if you look at the code here, in order to find the issue number, what we are doing is that we are checking if the JSON contains issue, okay, we take issue number. If it contains pull request, we take pull request number. If it contains none of that, we throw an exception. So this exception is supposed to be thrown, supposed to be raised if the JSON doesn't point to any issue in GitHub. but it will not be raised here if we just create instantiate an object, because we don't give control to the object. There is no runtime phase for the object. You see, there's no exception. The JUnit says expected exception, but the exception doesn't happen. But the moment I start touching the object somehow, for example, checking the title, then it will break. Then it will say I'm not valid. I'm valid. I'm a normal object. I'm just pointing to you see, unexpected exception, illegal argument exception, yeah, illegal state exception. In this case, it's illegal state exception. But let's see. Let's take a look at this and. Yeah, that's my point. So the object, when we create it here, it is legal. It just points to information. It just points to dependencies, which may be in the wrong state. Which may have something which we don't like, which may have some information which is not suitable for our scenario, which is not acceptable for us. But it's not for us. It's not up to us to decide. I mean, us here. I mean this object. It's not up to this object to decide during the instantiation phase of how to deal with these dependencies and in which state they are now. Because the moment we instantiate here, maybe, at this moment of time, maybe there is one situation in GitHub. Maybe there is no repository. And then later, in a few minutes or in a few seconds, when we start talking to that remote dependencies, at that moment of time, they have something for us. And then later, they again may not have it. For example, here, if I create that repository here, and I say title, and it breaks because there is no repository there for this, for John, and there is no ticket number 1. But then later here, I may do something like that. I may say, okay, and now let's create it. So here we break. Here we have the exception. Because there is no such issue in the repository. But then we create repository, then we create the issue, then we get it already, and then we do it again. And here there will be no exception. Exactly the same object, issue. But at this moment of time, it is, you may say, broken, like invalid, because it throws an exception when we're trying to get the title. But then in a few seconds later, when the repository is all of a sudden there, and it has the issue, it has everything we need, then there will be no exception. You don't trust me? Let's try. I'm sure you understand what I mean. Try, let's, suppress, let's swallow the exception here. Okay, and then we do it again, and there is no exception. So if I run this test, it will pass. Maybe not the name of the repository is wrong. It should be hello, not test. Sorry. It should be hello, yeah. Because here, look, John hello. See, it's green. So we had an exception here because there were no issue, and then the issue is all of a sudden there, and the same object on the same call on the same method says okay, no exception. So my point is that an object, we cannot call an object invalid or broken because one of its dependencies are broken. That's just the wrong way of thinking. An object is valid and solid and correctly instantiated if it managed to pass the constructor. If everything which we gave to the object was everything was encapsulated and then the object says, okay, now talk to me. And then we start talking to the object, and sometimes it may throw exceptions, sometimes it may react properly. It depends. The object may stay alive for hours. It may stay alive for days, and may happen in many threads. It can be transferred from from class to class, from place to place, and it may throw exceptions sometimes, but it's still the same object. It's still solid. So it is valid. The object is valid the moment it is instantiated. So it's just not correct to say that some object is not valid after you instantiate it. But sometimes, and now let's talk about the second scenario, the second use case. Let's say we have a really broken dependencies, fails on incorrect arguments. Let's say here, instead of GitHub, I'm gonna pass null. You see, the compiler doesn't fail. The compiler doesn't complain about that. And let's make it even worse. Look, here's the code. So let's say I make a mistake, and instead of providing the proper objects in there, I send null and null. This is what we would like to catch in the constructor. At the moment, the constructor is kind of blind. It would ignore that. It will still encapsulate null. It would still make, an object alive. But that is a scenario which I would consider a pre-runtime situation, a before runtime, when we don't want that object to be alive, to be born, because the input is wrong. Because the input is so wrong that we can catch it before the runtime, phase, even before we get control. So if I put here the check and say if so that's a legal, is a properly designed class, and this is the legal use case, the legal use of the code inside constructors, because we're checking what's coming in, and we don't want the object to be born, we don't want the object to be instantiated, we don't want to let anyone give control to such an object. Why? What's wrong with null? If we let the null stay inside, then we will most probably have some issues here and there after the object is born, and it will be very difficult to understand why our code fails here with the null pointer exception. It's better to catch that situation here and return the stack trace, which will point to the right place where the abuse is coming from. So if we do the check like this, then the exception will be raised with the stack trace, which will contain this line and then the line of the method, of the class, of the code which called us. And it will be easier to trace back and understand where this null is coming from. But if we let the null be encapsulated and then become our attribute, then the stack trace will be coming from here, which will not show us the place where the null was originally created. See the logic? So that's why it's better to raise from that point. It's better to not allow that object to become alive, to become instantiated. So if I run it here, of course, we will get a legal argument exception without even running any code, without calling any methods of this object. Let's run it and see. Yeah, the test passed, you see. So that was my, that's everything I wanted to show you. So let me, say a few words again to reiterate on the problem and then on my point. So we have two separate cases, two separate set of situations. The first situation is when we instantiate an object, we encapsulate dependencies in it, they become attributes, and then we let the object live. then we'll let the object do something later. So we give control to the object sometimes. We let the object do something in runtime, and then the object may throw exceptions when those dependencies are returning something which the object doesn't like. And it may happen many times. There will be many exceptions at any particular point in the lifetime of an object. It may happen, but that's a first case. For all these runtime issues, we don't need to touch the objects in constructor. We don't want them to be touched inside the constructor. We want the construction to happen quietly as possible. We want runtime problems to happen when we give control to the object, after instantiation phase. That's the first situation. The second situation is when the object says, you're giving me something which is not what I would like to work with no matter what. So I don't need runtime period. I don't need your control. I don't need to have control. I'm ready to say right now that what's coming in is no good. And it will never change later, like this null, for example. It will never change. So no matter what happens to me, it will always be something wrong. Like, for example, you are encapsulating, for example, I don't know, this is the strongly typed language, Java, but if that would be Ruby or PHP or some other language, JavaScript, which is not strongly typed, then we may say that, look, we need a specific type here. We don't want this to happen, this GitHub to be a string or a number. We want a specific type. So we will say that, you know what, we're not going to create an object. There's no point of making an object because the data which is coming in are completely inconsistent or completely wrong. So there are two situations. In one case in runtime, we check inside methods. We do validate objects inside our methods. In another set of use cases, we do it in constructors. So that's all I wanted to say. Let me check your questions. Let me look at the questions you have. There's a few questions about how I use Hemcrest. Well, you can use it the way you want, but the start with is good enough. So sometimes you can do equals, but if you do equals, you will have exactly the same string literals there, and then you will have to move it outside and call it title. So it will be a little bit more code. So that's why I'm using start with. Also, why not throw unchecked exception instead of normal IO exception? Yeah, that's true. You can throw IO exception. I'm in general in favor of checked exceptions in Java. So if you can throw checked exception, I think it's better. It's better to have checked exceptions. And also there's a question about setters. We're talking about setters here. Well, of course, we don't want to see any setters in our objects. So that's probably a subject for another webinar, the webinars we had before. But we are talking only about immutable objects here. Another question is, the new version of C# will likely have non-nullable references introduced. I suspect that Java might try to implement a similar feature too. I totally agree. I agree that my opinion about null. I'm totally against any use of null in any places of the code. So if Java can introduce some built-in validators for incoming parameters and just make sure that null is never coming in, that will only be great for the language. If C# already has that, that's perfect. It doesn't mean I love Microsoft after that, but that's a good feature for the language. In case we receive a truly constant object, so it's 100% immutable in the constructor, can we validate there and not in runtime? Well, yeah, it's a good question. I mean, you're saying like if, for example, we're getting the string in there, right? A piece of text. So we know that it's not going to change itself in runtime ever. It will stay exactly like that. I would still recommend to let as many errors to happen in runtime as possible, and only the very limited set of very obvious mistakes to happen in constructors, like wrong type or null or something like that, which will help us to break the instantiation phase period, the instantiation timeline. So when you know how application in object-oriented programming usually works. So first you instantiate all your objects, you build a more complex object, they all stay together, and then you let them work. So there are two phases. The first one is instantiation, the second one is runtime. So the more errors happen in runtime, the better. Only the very specific cases like null, different types, wrong types, and all that like that we move to the first phase. That's what I think. And also there's a good comment about Kotlin. Kotlin has that feature for null checking, which is a really good feature. So I would definitely recommend to try that language as well. So that's it for now. Thanks for listening. I think I said everything you needed to hear. Try the blog posts. I have two of them. One is called Object Validation Defer or Not, and the second one is Constructors Must Be Code Free. That should be enough to get the gist of the idea. Thank you very much, and see you next time. We meet every Wednesday, every first Wednesday of each month at 11 in the morning Pacific time. Thank you very much. Bye bye.